Every company uses an ATS system, an application tracking system, to filter out resumes. And the most of them works in a very particular way. Let's say they will just control F your resume, and if your resume don't have that exact keyword, you are rejected, even if you are actually a good candidate. So let's say if there is someone who built ML pipeline, might get rejected for a job that says machine learning engineering experience required. Same thing, different words, rejected. Today we are going to fix that. I'm going to build a semantic resume matchup using Qdrant, a vector database, and we are going to find candidates based on meaning, not solely based on keywords. And I will show you the exact moment where this system does something a traditional ATS literally cannot do. Alright, so let me give you a quick tour of what we are building today. Before we dive into the code, have a look at this. We have a pool of 12 candidates like engineers, data scientists, DevOps people. Each one has a resume written in, let's say, plain English. We are going to store all of these like resumes, right? Like let's consider this as one resume, this as one resume, right? In the form of vector. And then when we get a job description, instead of searching for keywords, we are going to ask Qdrant which resume meanings are closest to the job description meaning. And the result is ranked list of the most relevant candidates, complete with a match score. We also have a bonus feature at the end, candidate to candidate similarity, like find me more engineers similar to this one. Really useful for talent pooling, I would say. So let's get into it. So first things first, we will install some libraries, which is Qdrant client and sentence transformers rich. Look at this. So Qdrant client is basically, as I've said multiple times, that is how we talk to our vector database. And sentence transformer, like let's say this is what converts text into vectors. And rich, this thing is basically just to pretty output in notebook. So let's run this and wait for its installation. So from here we will just import everything, and from here, as you can see, we are using Qdrant Cloud. It's really easy to sign up. Go check it out. Right, you'll get your Qdrant URL and your API key, and as you can see, this is our all mini LM L6 V2. This is our model of like sentence transformer, which will be used further. As you can see, when we run this, look at this. And as you must have noticed, this model outputs 384 dimensional vectors. So what does that even mean? Every piece of text, whether it's a resume or a job description, gets converted into a list of 384 numbers, and those numbers capture the semantic meaning of the text. Two texts that mean similar things will have vectors that are close together. In that 384 dimensional space, that's the whole idea. Now, we will create a Qdrant collection. Think of it like creating a table, let's say, in a database. Except this table is optimized for vectors. Let's run this thing. Look at this. Collection resume already exists, so it will create the creation this time. We set the vector size to 384, matching our model output, and we use cosine similarity as our distance metric. Cosine similarity measures the angle between two vectors. It doesn't care how long the vectors are, it only cares about direction. That's perfect for texts because we want to compare meaning, not the length of the document. Again, getting back to our resume cell, here we have 12 candidates. As I've already showed you, I have written their resume as natural language summaries, similar to some LinkedIn profile, let's say, or LinkedIn profile summary. Notice something important. None of these resumes are keyword stuffed. They describe skills and experience in natural language. For example, let's say this person Aryan Mehta, right? Here it says that they built and deployed machine learning pipelines, correct? And not machine learning engineer. Let's say another person, Meera Nair over here, correct? Meera Nair talks about semantic search systems, not vector search, not Qdrant specifically. A keyword based ATS would miss half of these. Let's see what Qdrant does now. So before we move ahead, let's first load this into our Qdrant. As you can see, loaded all 12 candidates into, all of their resumes into our Qdrant. Now, we embed all these 12 resumes into one batch call. That's efficient. A model processes all texts together and returns a 2D array of embeddings. Then we package each embedding into point struct, as you can see, right? That's Qdrant data format. Each point has an ID, let's say the vector, which is 384 numbers, and a payload. That is just a dictionary of metadata, name, role, year of experience, and the original resume text. And have a look at this thing, client.upsert. We upsert them all into Qdrant, all 12 of them at once. As you can see, look at this, all 12 resumes stored in Qdrant. Now, the next is core search function. Let me walk you through what happens. We take the job description text and embed it into the same model, the same 384 dimensions, let's say. Now it's a vector, correct? Or let's say there is step 2, which is optional. We build a metadata filter. Qdrant lets you combine vector search with traditional filters. So you can say only search among candidates with 5 or more years of experience. This is really powerful. You're not choosing between semantic search or filtering. You get both simultaneously. Or step 3, we call client.search. As you can see, look, correct? We do this. And we give it a job description vector or tell it how many results we want and pass it in the filter. Qdrant does the rest. It finds the closest resume vectors using approximate near neighbor search. The result come back with each candidate's payload and a similarity score between 0 and 1. Higher is obviously better. So let's run this and check what it looks like. So as you can see, our function is ready, and if we will run this thing, look at this. We got all 5 people, right? First is Aryan, he is ML engineer, 4 years of experience. Math score is near to 1, not obviously not even near to 9 or 8, but it is highest among these people, right? That is why it is saying that, hey, this is an excellent fit, this is an excellent fit. These are good, this is good, and this is fair, as you can see, because he has most experience and this is the most relevant role. That is why. Now these were some good results, but this one was kind of expected, let's say. Now let me show you more interesting one, which is our second test case, this one. So as you can see, the job description is seeking an engineer to build LLM powered application and embedding pipelines. We will work on RAG and fine tuning transformers and whatnot, correct? So as you can see, Meera is the first, best candidate over here. As you can see, 3 years of experience, NLP engineer. Look at this. Why? Because they want RAG system, they want fine tuning, fine tune transformer models, and that is why she is first over here, right? Qdrant returned exactly the right people because it understands the meaning. That's the whole pitch for vector databases right here. Look at this. Now the third test, which is our third test case, let's say. So as you can see, they want they are hiring a senior cloud infrastructure engineer for our platform team. We will own cloud architecture, manage container, and as you can see, more is here as well. 99% uptime for critical servers. You must be comfortable with monitoring incident response and all on-call rotation. So according to this intent, correct, Karan Joshi was the perfect candidate. Even though we have the cloud architect, but reading Karan Joshi's resume, Qdrant thinks that hey, Karan Joshi is more is better as compared to Aditya Kumar. Why? Because Karan Joshi's resume might have something which is pitching himself or making himself look better than Aditya Kumar's resume. If it was a keyword search, let's say, then we wouldn't even see Karan Joshi, who is the first candidate over here, who is the most let's say suggested candidate over here. Why? Because his role is DevOps engineer, because that would be a keyword search, but here we are doing semantic, that is why. So one query, semantic search and structured filter. Qdrant handles the both. So this is our last test case. Let's run it and let's see how it looks like. So the job they are looking for, they are giving is they are looking for ML machine learning operations and data platform engineer to accelerate our AI teams, blah blah blah. As you can see, this role sits at the at the intersection of software engineering and data engineering and machine learning. So let's see who can actually do this. Here keyword based matching system would absolutely fail. I can guarantee you that thing. But here, as you can see, Pooja here is the first and the most reliable candidate over here. She is ML platform engineer. Even though we have Karan Joshi, who has 6 years of experience, but he is DevOps engineer, right? And his resume might not match that much. So we have got correct people for this sort of job description as well. Now, the most awaited bonus feature, candidate to candidate similarity. Qdrant has a recommend API. You give it a point ID and it finds the most similar other points. No re-embedding needed. It uses the vector that's already stored. We let's say we anchor on Aryan Mehta, who is our ML engineer, and Qdrant finds the most similar candidate that is useful for talent pooling, building team diversity reports. Or when a recruiter says, find me 5 more people like this, right? So let's run this and let's look at this once again. Let's say, yeah, as I've said, I want someone like Aryan Mehta. As you can see, this person who is Pooja Iyer, who is ML platform engineer, is very much similar to this. So as you can see, we didn't embed anything new. We didn't put any new logic. We just we just wrote our code in such a way that it will find the similar person to Aryan Mehta. Look at this. Isn't this good? Now, let's take a quick look at our Qdrant stats, or you can say our collection stats. Points stored 12, collection name is resumes, and vector dimensions are 384, and distance metric was cosine and status is green, which means let's say it's on, correct. So here I have left something for you all. You can try this by yourself, or you can put your own job description over here, or you can make new cells over here and try it by yourself, like how it actually works. Like I will be attaching this on our video's description so you guys can use it. So that's the smart resume matcher built on Qdrant. What I really want you to take away from this is traditional search is about finding exact matches. Vector search is about finding semantic matches. And for anything involving human language, that is resumes, job descriptions, documentation, emails, semantic is almost always the right approach. The real world extension of this would be connecting Qdrant cloud instead of memory. That is why we have used the cloud one, right? Sometimes we can also use the in-memory one, correct? But the core, the search engine itself, is exactly what you saw today. If this was helpful, drop a like. If you want me to build something more, or if you want me to explain even more, or if you have some examples of yours, then please do